Alright, hey geometry students. So we're on our last lesson in chapter 9, this intro to the trigonometry. And we're looking at law of cosines and law of sines. So we're looking at how to find the areas of triangles. That's what we're going to be learning today. And using these laws of sines to solve triangles and cosines to solve triangles as well. So far what we've been doing is solving right triangles, and we can solve a non-right triangle with these laws here. So that's really what the laws are for, is when we want to solve a triangle that is not a right triangle. That's what we can use these laws for. So that's what we'll learn today. Alright, but first let's go ahead and just look at a little cartoon. They're in the bleachers here today. This coach is telling his young boys, take the field, and remember, your parents are counting on you to achieve their unfulfilled dreams of sports glory. Like this one little kid right here. Ah! He's running out to the field. Alright, so let's jump into what we're doing. Okay, so on page 276 in your extra practice 1 through 3 is kind of just a little review. Go ahead and pause the video for a minute, take your calculator, and just find the sine of 225, cosine of a 111, and tangent of 96. And then play it again. Just make sure you get those right on your calculator screen. Okay, so hopefully you got those numbers down and you can just now check them. So the sine of 225 on your calculator screen, remember all you're doing is just like hitting the sine button, hitting 225, and then equals. Or on some calculators you got to put 225 and then hit the sine button and then equals. So sometimes it's one way, sometimes it's the other. Just see which what do you have to do here. So this one is going to be negative 0.7071. Remember it says 4 decimal places. For the cosine of 111, that was negative 0.3584. And for the tangent of 96, that was negative 9.5144. Alright, so just if you didn't get those right, then go back to your calculator and see maybe what you did wrong and see what you need to do to get those answers correct. If you're still struggling, then see me in class and I'll help you out. Okay, so this first core concept here, which is about the area of a triangle. So if we're trying to find an area of a triangle, then we have a formula for that. We know 1/2 base times height is always what we've been using for the area of a triangle. And that's fine if you have the base and the height, or you're able to find the base and the height. But in this situation, we're not going to be able to find something. So we might know, basically we might know, 2 sides and 1 angle. And that's what we have here. So if you know 2 sides and 1 angle, it's not just any 2 sides and 1 angle. It says the area of any triangle is given by 1/2 the product of the lengths of 2 sides times the sine of their included angle. So basically it's a SAS situation. So if we know side A and B and we know the included angle here C, then we can use this to help us out. And basically, I know that gives you 3 of them here, but basically what it is it's 1/2 times the 2 sides you have times the sine of that included angle measure. And that's what it is really here. They're giving you all different ones, but that's okay. It's the same no matter what. So as we see it, if we just remember, if you have an SAS situation, you can find the area of a triangle with trigonometry and with using the sine. Specifically the sine ratio, to be able to find that area. So let's go ahead and try a couple now on our extra practice. So 4 and 5, which says find the area of the triangle, round your answer to the nearest tenth, 1 decimal place. So on number 4 we have 14 and 9. The included angle here is angle C. So C is our included angle. So what we're going to be doing now is finding the area. We're going to write out that formula. Basically it's going to be A equals 1/2 times the 2 side numbers, 14 times 9, times the sine of the 79 degrees. And that's all it is. So it's 1/2 times the 2 sides you have, and times the sine of the included angle. Remember, it's side, angle, side here. This only works with this situation, side, angle, side, for finding the area. And now just using our calculator, we can then work this out. We could start with the sine of 79. We might want to start there and then multiply all the rest here. That's fine. We can also see 1/2 of 14 would be 7. So we know that this is going to end up being 7. 7 times 9 is 63. So we know this is going to be 63 times the sine of 79. We can just do that. So I can say 63 times the sine of 79 degrees. Actually, I'm going to find the sine of 79 degrees first. I'm going to plug in the number first, 79, and then sine, and then times 63. And there we go. So 61.8 is where the 1 decimal place would fall. And so there's our answer, 61.8, and it would be square units because we're finding the area. Go ahead and try number 5, same thing. Just fill it in with this little formula. It's half times the two side numbers times the sine of that included angle measure. So pause the video for a minute and do 5 and then play it again to see if you get that right. Okay, so hopefully you've already tried this one. You have an answer for it. So you should have filled it out like this. The area equals 1/2 times 19 times 22. That's our two side lengths times the sine of 24 degrees. And so we could say 1/2 of 22 is 11. So that would be 19 times 11 there. So if I find the sine of 24 first, so if I do that, so I gotta hit 24 on this one. I have to hit the number first, then the sine button. So there's my sine of 24 degrees. Then I could say times 19 equals that, and then times 11. Times 11 equals my final answer, 85.0 basically. So that would be 85.0. So you should have got about 85 square units then on that, or you could say 85.0 square units. Okay, so now on to the law of sines. So in your vocabulary on page 274, this is what you want to write down for the law of sines. So the law of sines, you use the law of sines to solve triangles when two angles and the length of any side are shown. So you can have an angle side or an angle side angle case, or when the lengths of two sides and any opposite angle of the two sides are shown. So that'd be a side, and an angle case. Basically, if you have, you got either two angles and a side or two sides and an angle, you can use the law of sines for this. And this is the law of sines in this theorem. You can see it's basically three fractions equal to each other. So you have the sine of A over side A, sine of B over side B, sine of C over side C. So you have your angle measures here next to the sines. These would be our angles up here with the sine of the measure of angle A. So the capital letters are the measures of the angles. These lowercase letters here are the side lengths. And it shows you can have it this way where you have the sines on top and the side lengths on the bottom, or you could do it this way, it doesn't matter, where the side lengths are on top and the sines of those measures of the angles are on the bottom. Now sometimes one is better than the other on a particular problem, and we might talk about that as we get into them. But this is what we're going to do. If we know some stuff over here, we're just going to fill it in. We know some angles, we're going to fill them in for the A, B, and the C. If we know some side lengths, we're going to fill them in. And then we need to figure out, okay, what proportion can we solve? And so that's what I want to show you here just real quick. We'll look at this problem right here. You can see here's an example of one. We have an angle here and then two sides. So basically side, and an angle is what we have then. And so we can plug it into the sines here. I put the sides on the top. So I put for A, we have A would be opposite angle A, remember? And B is going to be opposite angle B. C will be opposite angle C. So I just don't know the side C. So I know A is 20, B is 11, but I don't know C. And then for the measures of the angles, I do know angle A, so sine of 115 degrees, but I don't know B and I don't know C. And so what we can see here is that I can figure out, I just need to figure out which one I can use. So I have two of them I don't know here, so I can't use this one first. That's why I put a box around this one. So we could find the basically the measure of angle B on this one to be able to do this. We can find the measure of angle B to do this. We could also find the side lengths using different ways. If we know one angle though, as soon as we find B, we can find that third angle because the angles all measure up to 180. So that's another thing you want to know, is that once you find the second angle, you can find the third one just by subtracting the other two from 180 degrees. And that's what we'll see. Here's another one where I have one side but two angles. So this time I put the sines on the top and the the side lengths on the bottom. So I don't know A, so I have sine of A. I do know B, that's 25, so sine of 25. I know C is 107, so sine of 107. And on the bottom, I don't know side A, but I do know side B right here, which is opposite angle B. That's 15. Side C, I don't know that one. And so on this one, I could find out what the side length is. Basically, I want to find this side length first. I could measure the angle also right here. I just know that one's going to be 180 minus 107 minus 25. That will give me my measure of angle. And then finding the side length, I can use my law of sines here just with two of them. You only want to take two at a time as a proportion, cross multiply, and then solve. Alright, so let's go on to some extra practice problems. Actually, first, before I do the extra practice problems, there's one more I wanted to show you here. And this is a little word problem. So the surveyor makes the measurements shown to determine the length of a bridge that's to be built across a small lake from the north picnic area to the south picnic area. Find the length of the bridge. So north picnic area, so basically A to B. We want to find the length of A to B, which really is C on this one. And so we want to use the law of sines to do that with. So we're going to start to see the law of sines here played out. We're putting the sides on the top. And that's because I really want to know a side. If I'm trying to find the side for sure, that's when it's best to put the sides on the top. If I'm looking for an angle, then it would be probably best to find the angle. So if I know my angle measures, it's better to put all those at the bottom. Any variables that you don't know you're trying to find, is better to have them on the top. So this one, I'm going to put the sides on the top, angles on the bottom. They found that third angle really quick by 180 minus these other two, giving us 49. So there's that B angle right there. We're trying to find C, really, on this one, so I could just do this right here, cross multiply. So basically, if I multiply this sine of 60 times 150, that would equal C, and then I could just do that. And that's what we want to do here. They're just going to use those. We're going to multiply the sine of 60 times 150, so now it's on the top. Sine of 49 is on the bottom. We would use our calculator just to do this with, and so that would then give us an answer here of 172.1. So we would do that. We could also find out what A was, and then we could even find the perimeter of this whole thing if we needed to. Once you know all three sides, you can add them up and know the perimeter as well. Okay, so here are our back to page 276, exercises 6 to 8. Solve the triangle, round decimal answers to the nearest tenth. So we can see these triangles are not right triangles. And so that's why we have to use the law of sines to be able to help us with that. That's what we're going to do on these two at least, for 6 and 7. So on this one we can see we have one side length, we have two angle measures. So if we know two angles, we can find this third measure right here. We do need to find also these other two sides as well. So we need to find basically the side opposite A would be A. So we need to find that side. We need to find also the side opposite C, which would be C. We know basically what B is. The side B would be 22. And so also we need to figure out this angle measure right now. Let's do that first. That's going to be the easiest part. The measure of angle C is going to just be 180 minus 50 minus 30. So that's just going to be 100 degrees. So our measure of angle C right there is just 100 degrees. And now we need to plug it in, plug everything we know. We know the three angle measures now. We also know one side. Plug that all into your law of sines. And since we are looking for the sides, we probably should put the sides on the top. So that way the sines of those measures are on the bottom. That's going to be a lot easier for us as we try to solve it. So we have we don't know A, but we know the sine of A is 50 for 50 degrees for angle A. We do know B, that's 22, and we also know the angle B is 30 degrees, so sine of 30, and it's equal to C, we don't know C, over the sine of angle C, which is 100 degrees now. And so now we can just, looking for A and B, we want to look at these first two fractions right here as a proportion. And so we're going to do that first, do a proportion out of that. So A is going to equal this fraction now, because what we can do is we can cross multiply with this, and since I just need to get A by itself, this is why I put the A on the top and not on the bottom, because now I can just multiply the sine of 50 times 22. So our 22 times the sine of 50 on the top. This now goes up here, So sine of A. So basically you're multiplying both of these by the sine of 50. So sine of 50 goes up with 22. So now it's the sine of 50 times 22 over the sine of 30. And so that's what we can do on our calculator now. So I want to come over here to that. So we say, okay, the sine, I'll do the sine of 50 first. So 50 sine, and then I want to multiply that times 22. And it equals that decimal. Now I want to divide this by sine of 30. So 30 and sine. So that's what dividing is. It's 0.5, and I hit the equal button again, and I get 33.7. I want the one decimal place, right? The 10th. So 33.7 should be the side for A. So 33.7 is our A. And then we're going to use these two to find C. And where I'm going to now try to solve for C by moving the sine of 100 up with the 22 this time. So that's now going to be C is equal to the 22 times the sine of 100 divided by that sine of 30. So coming back to our calculator. So I'm going to do 100 and the sine of that times my 22. And that equals that number. And I have to divide this by the sine of 30, which really was 0.5, but I'll just show you again. The sine of 30 is 0.5. And equal 43.3 is my one decimal place on that one. So this one's 43.3. So that one is now completely solved. I found all three angles now I know, and I know all the three sides. So number 7, I have only one angle. So I'm going to have to find one of the angles first here. And I have two sides. So we're going to have to just jump right into putting it into our law of sines and cosines, or just law of sines, I'm sorry, on this one. I haven't done yet law of cosines yet. So I need to know this angle for angle B. I need to know this angle again also for C, but I'm going to find B first. Now you have to decide which angle you want to choose to find first. I've just decided to choose to find B first. And also we're going to find out what C is. We need to know what that is as well. We need to know side C. Alright, so as we start to think about that, if I'm going to find measure of angle B, then I can put my angles on the top with the sines. Those should be on the top. I know the side lengths. So I know two side lengths here. I know side A and side B. That's why I want to use, that's why I basically wanted to find out this one first. So I really couldn't find C first because I didn't know side C. So I have to use finding B first because I do know B. The side B is 16. I know both for A, angle and side. So as we start to put those in, I'll actually include this one here, the sine for C over C. But really we're just looking at this one right here. So we're really just kind of looking at that proportion right there where I'm going to put for A it's 82 degrees and for side A it's 25. We don't know sine of B, but side B is 16. And so now we want to solve for the sine of B. So I'm going to do the same thing, but this time I'm going to move the 16 up to where the sine of 82 is. So that's going to go now up here, multiplying the sine of 82. So sine of B will now equal that fraction of 16 times the sine of 82 on top over or divided by 25. So we want to look at figuring out what this is here. So when we got to figure out what that's going to be there as a number. So we need to figure out as a number that's what this is going to be. So you can find that out by the calculator again. Just really fast we can do sine of 82. So I had 82 sine and then times it by 16 equals that number, and then divide it by 25 equals the number I got here, 0.633. I rounded it up to 8. I went 4 decimal places here just for a little further because we're not getting the answer yet, so I don't want the 10th yet until my very answer. So now since I'm trying to find the angle measure, we have to use the inverse sine now button to find the angle measure of this. So that's what I need to do next. I'm going to have to find the measure of angle B is going to be the inverse sine of this. So basically I'm zapping both sides with the inverse of sine. And when I zap it with this side, the sine goes away, and now I just have measure of angle B. And over here I have the inverse sine of this, 0.6338. And so now I need to hit I already have that on my calculator really right here. So I can just hit my inverse sine of this. I should be able to. Let's just see if this works. Inverse sine of that Yeah, it gives me 39.3, and that should be my answer. So 39.3 is the measure of angle B. If you didn't, you can just put the number in and hit the inverse sine button. Or the calculators in classroom where you would hit the second button first and then hit the sine button. You know, that's what you do for the calculator in class. Second button, then sine button, and then you'd hit the number and then equals. Alright, so we know that angle now. So this is 39.3. I can figure this one out by just the triangle sum theorem. So 180 minus 82 minus 39.3, that equals 58.7. So the measure of angle C is 58.7 degrees. So now I know that angle there. So the last thing I need to find is C. So now this is where we want to go back to this one here. So we know the measure here is 58.7. I can fill that in. And I could use this now with either one of these two. It doesn't matter which one you pick. So I'm going to pick the first one. So I'm going to pick A. And notice I put now since I'm trying to find the side measure, I'm going to put the sides on the top and the sines of those angles on the bottom. So I flip this one upside down. So it's 25 over sine of 82. I'm going to flip this one as well. So C is over the sine of C, which is at 58.7. And now to solve for C, we do it like we were doing over here. I'm going to multiply 25 up here by the sine of 58.7 to find out what C is. So C is equal to 25 times the sine of 58.7, all divided by the sine of 82. Let's bring back our calculator. And so let's go ahead and put in the sine of 58.7. So 58.7, sine of that is this long decimal, times that by 25. That equals this decimal here, 21.3, so on. But then I need to divide it by the sine of 82. So divided by 82 and the sine of that. Okay, I just have to hit equals to get my answer now. So 21.85 should be my answer. Wait, that didn't seem right. Let me double check that one. Is that right? Yeah, it is 21.6. So there it is. 21.6 is my answer. I'm going to round this to one decimal place. Okay, so for this last one, number 8, what we're given on this one is we're given all the sides but no angle measures. So if I was to try to use the law of sines like I've been using here in these last two, it would be like this. We could put all the angles on the top, or I should say all the sides on the top since the angles on the top since we don't know any of the angles. Sides, we know those, so those should probably be on the bottom. So it could look like this. Actually, I did it wrong, actually. I did it the other way. But the point of this was for me to show you that there's no way I can use the law of sines to find the angle measures. Because if I was to take two of them, there's two things I don't know. I have to only have one unknown to be able to cross multiply to solve for something. So right now I don't know two things here. If I try to go to these two, I still don't know these two. With these two on the end, I still don't know the A and C. So there's no way to use law of sines to be able to do this one. This would be an SSS situation, side, side, side. Well, when you have that situation, that's going to be now reserved for the law of cosine. So let's go on to that one so we can see how we could do number 8 then. First, let's go ahead and just do a quick little joke of the day here before we end. So where do animals go when their tails fall off? The retail store. So there you go. Okay, so back on page 274 now in the vocabulary, let's write this down for law of cosines. You'd use the law of cosines here to solve triangles when two sides and their included angle are shown, or when all three sides are shown. So the SAS case or the SSS case. Either one of those is when you want to use the law of cosines. So here is the law of cosines. Now this one is a little more challenging than the law of sines. I'll definitely admit to you that. The law of cosines is a little more challenging to remember typically than the law of sines. So we got our lengths A, B, and C here are shown. And here we go with this. It's A squared equals B squared plus C squared minus 2BC cosine of A. So it really kind of depends on what you're trying to find, on what you're going to use. So if you're going to try to find, angle A, well, then you want to use this one. If you're going to try to find angle B, then you're going to want to use this one. Or angle C, you're going to want to use this one. So basically, the whatever angle you're going to try to find, the side gets squared. It's going to equal the other two sides squared added together minus 2 times those other two sides times the cosine of the angle you're trying to find. So hopefully that will start to, make itself very clear as you start to do some of the problems on the big ideas assignments. But that's basically what you want to realize, is that if you're trying to find angle B, let's just say, then you want to start with b squared equals. The side for b here is b squared equals, and then you're going to add together a squared plus c squared. So these two here, these other two are going to be, everything's going to get squared here, but a squared and c squared will add together. You're going to subtract that from 2 times a times c, and then multiply that all by the cosine of b that you're trying to find. So that's going to stay a variable, remember. Unless you know, your angle and you're trying to find a side. Typically we try to find the angles on these ones though, like we were doing the side, side, side one. So let's go ahead and try that on this here. Actually, first I wanted to show you one with the SAS situation, because our number 8 problem is the SSS. And here again, you can see if I try to plug it into my law of sine, it's not going to work. So I know B, the angle for B, and I know sides A, and I know side C. So A is 11, but I have a sine of A. I don't know side B, but I have sine of 34 because B is 34 degrees. I know side C is 14, but I don't know the sine for C, or the measure of the angle of C. So that way, if I tried again, just taking 2 of those, there's 2 things I don't know. Now I don't know B there, I don't know A here. Or these ones, I don't know B, I don't know C here. Or even in this one, I don't know the A and the C for the measures. So there's no way I can use the law of sines when I have an SAS situation. So here's what we'd be doing. We need to find, use the law of cosines to be able to do this. It says use the law of cosines to find the length of B, and that's fine, you can do that. You can find the length of B first. So if you're trying to find the length of B, then we can put the B here, and we can use it where it's B squared. That's where we want to try to do that. And we're going to do the A and the C. That would be these 2 times each other. Or I should say not times each other first, but they're going to be squared and then added to each other, minus 2 times these 2 numbers times each other, the 14 and the 11. So everything gets plugged into that. And we have a cosine of 34 degrees. And so we just calculate this all in the calculator, and eventually you're going to take the square root of both sides because you have a b squared here. So that's eventually what they're doing. As we go through this, the square root of all of that, and eventually get your side length is 7.85. They can use the law of sines then at that point. Once we know what one of them is, we can then eventually go back to the law of sines, because if this is now 7.85 right here, well, now I can take these 2 and find that measure of angle A using the law of sines again. So I really only need to use this law of cosines once before I can go back to using my law of sines to figure out the rest of them. Okay, so here we are back on number 8 from page 276. Now the one that has the SSS situation. We just need to pick one of the angles to find first. It doesn't matter which one you pick. I think I'm just going to pick A to find A first. And so we're going to use the one that starts off with A squared and has the cosine of A at the end of it, which means, okay, if it's A squared here, then it's the B squared plus the C squared. It's almost like the Pythagorean theorem sort of here, minus 2 times B times C. So remember, it's always these 2 times each other in here. So B and C are here, and also B and C are here, and then the cosine of A. So we just fill everything in we know. So we know everything. We know A, we know B, we know C, we know this B, we know this C. We just don't know cosine of A. And so that's what we're going to fill in. So 5 squared, 7 squared, 3 squared, minus 2 times 7 times 3. That's your B and your C. Remember, B is opposite, so that's why B is 7. C is opposite of angle C, that's 3. A is opposite angle A, so that's why A was 5. And so now as we start to work this out, we got 25 here, 49, that's 9 in there. So we start to multiply some of this together. We got 7 times 3 I multiplied to give us 21 here. And then we start putting this together. We need to put the 49 and the 9 together. That's going to make 56 right there. We can also multiply 2 times 21. That'll be a 42. So we can see that. So we have 58. I said 56. I meant 58. This is 58 minus 42 times this cosine of A equal to this 25. So at this point, this is kind of like an equation at this point as we're starting to simplify this all out. Because here's your variable. The cosine is like your x. So if you pretend this is like x here, we got to move the 58 to the other side where 25 is. So I got to subtract 58 from both sides. So that's going to give me a negative 33 is equal to a negative 42 times the cosine of A. And then I got to get rid of this negative 42 in front of this cosine of A. So that means I have to divide both sides by the negative 42. So that's going to give me a positive number now here. So I'm going to see, as I figure out, okay, I got these cancel out. I have cosine of A is now equal to a positive, this decimal right here. Let's go and just see that. So we can see if I did 33 divided by 42, right there, that's going to give me my decimal. 0.7857 is what I did. I went 4 decimal places here, even though I know it says go to 1. That's when we get our answers. We're not getting an answer yet. So now I just need to see that I'm trying to find the angle measure. When you're trying to find the angle, that's going to be the inverse of the cosine. So I need to zap both sides basically with the inverse of the cosine to undo this cosine. So that way I can free my angle measure and then give this the inverse of the cosine here. So I'm going to do that. So it's got the measure of angle A is equal to the inverse cosine of 0.7857. So I already have that decimal on my screen here. We just need to hit the inverse and the cosine button, and there it goes, 38.2. So I want to go 1 decimal place now. 38.2 is what we're seeing. So the measure of angle A is 38.2. So once we know one measure for an angle, we can then go back to the law of sines. Now I could do this again with the law of cosines. I could find them all with the law of cosines, but I think the easier way now, instead of going through all of this again, is to go back to the law of sines. And so we would see this, we'd plug this in. Here's our angles on the top, our sides on the top. So there's A, B, and C on the top here. The angles are now on the bottom. So now I have sine of 38.2 degrees because I just found A. But I don't know B, I don't know C. So I could find B next. So if I want to find B next, I can then do this, just these two. And I would want to find B by multiplying sine of, actually I should say it the other way around. I really should have flipped this upside down now that I'm thinking about it. That would have saved me a little bit of time. This is the situation I'm talking about. Why should you put the sides on the top sometimes, and then other times put the angles on the top? So on this one I should have put it the other way around, because as I multiply I'm going to still be on the top. So I'm getting a little more awkward, I guess, on this one. I went straight to this. So basically I need to see that this whole thing is now going to be the reciprocal of it here. So if I think of this as now 5 on the bottom and the sine of 38 on the top, and then multiply that by 7. So now 7 times the sine of 38.2 is now on the top, 5 is on the bottom. So hopefully that didn't confuse you as I'm doing this, but that's the whole reason why I'm saying when you're looking for an angle measure, that's best if it's on the top. So I knew all the sides, I should have put those on the bottom to make it easier. So that's why if you just think of this as reverse, we're going to multiply here to get this by itself. So 7 times the sine of 38.2, but now I got to flip that upside down, and now it's 7 times 38.2 over 5. Flip the sine of B over upside down, so now it's the sine of B there. So now I can just use my calculator to find out what this decimal is, and so I could do that down here. So 38.2, and I'll hit the sine button, times it by 7, and I got to divide it by 5. So that gives me that decimal, that long decimal. So that's what that is. I'm going to put like 8.8658 maybe over here, just to show what that is. So the sine of B is that decimal, 0.688 0. Did I get the wrong decimal here, or did I write it wrongly? Maybe I did that incorrectly. Let me see. Okay, so I think I just wrote this number down wrong for some reason. I don't know why. I'll have to fix that a little bit later, but just go ahead and write this number down instead. It's on the calculator screen, as you can see it here. Instead of this number here, you should be writing 0.8658 approximately, if you round that to 4 decimal places. That's what it really should be. I'm not sure why I wrote this one down. But then we want to again say we want to zap. If we're trying to find this, we're trying to basically free the measure of the angle, we need to zap both sides with the sign, the inverse sign. That will undo this sign here and free the measure of the angle. And so I have measure of angle B is equal to the inverse sign of this number. But again, don't write this number. Write the other number, which is this number here, 0.8658, or even 57, but 58 would be rounded better. And then we can just hit the inverse on my screen here. So I'm going to hit inverse and then hit the sign, and there we go, 59.97. If we're rounding to 1 decimal place, it's really 60.0 then, as we see this. So this should really be 60 degrees, and I wrote it correctly here. This is why I was confused, because I knew I wrote the right answer here. I'm not sure why the number here was different, where I got that number from. So I just fix that number right in there. But it is 60 degrees. The measure of B is 60 degrees. But now that once we know that, we now can take these two. We don't have to use any law of sines or cosines anymore. We just do the triangle sum theorem, 180 minus 60 minus 38.2 to give us this last measure. So the measure of angle C is 81.8 degrees. And there we go, we're done. So we've found all the angle measures that we need to find. Using law of cosines first, then we use law of sines, and then finally the last one we used is the just this triangle sum theorem. Alright, so that concludes our lesson, our last one here in chapter 9. So go ahead and finish up the big ideas assignment on 9.7, and I'll see you back in class.